In this video, I will show you how to make graphical analysis do calculations for you. I'm going to do two examples in this video, a simpler one about converting mass values and a more complicated one about circular motion. For the first example on converting mass values, I did a lab experiment in which I changed the mass of a car as it was pushed by a constant force to see how much it would accelerate. The trouble is that I measured all my mass values in grams, which is not the SI unit for mass, kilograms is. So now I've entered all my mass data in grams, but I want to convert it to kilograms. The math isn't hard. I know I just need to divide the mass in grams by 1,000 to convert to kilograms. And I can get the computer to do all that work for me. I'm going to begin by clicking on the three horizontal dots in my current mass in grams column and choosing Add Calculated Column. Here I will add a title, mass 2, and a unit, kilograms. Next, I'll click on Insert Expression and choose A times x to the b, which sounds complicated, but will do what we need. As I said before, all I want is for the current x values to be divided by 1,000, which is the same as multiplying by 0.001. So in the box for A, I'll put 0.001. I'll leave x as mass, and then I'll leave power b as 1 because I don't want to square or cube x. I'll just want to leave it as it is. I'll click Apply, and now we can compare the two sets of mass values in my table, one in grams and one that is 1,000 times smaller right next to it in kilograms, just as I intended. Success! If I want to show this new value on my graph, I will just click on the axis. In this case, I'll put it on the x-axis and choose my newly named column from the list. The graph automatically adjusts, and I'm ready to go. For my second and slightly trickier example, my experiment was to change the radius as I spun an object in a circular path and measure the time it took for one rotation, or the object's period. I want to know the speed of the object as it was spun in that circular path. I already know that speed is distance over time, but in this case, the distance is a circle, which has a circumference equal to 2 pi r. So I really want the computer to do the hard work for me to calculate speed as 2 pi r divided by t, or the time for one rotation. At this point, I already have columns in my data table for radius, my x variable measured in meters, and period, my y variable measured in seconds. So what I want to do is multiply my x values by 2 pi and then divide by my y value. I'm going to add a calculated column from the y column, or period column, by clicking on the three horizontal dots. Again, I'll select Add Calculated Column from the list. I'll make the title speed, and based on my units of radius in meters and time in seconds, speed will be measured in meters per second. Now for the expression. When I click Insert Expression, there are lots of options, but not many that include both x and y. I'm going to choose the one that says a times x to the b times y to the c. This expression means that I can add a coefficient, in this case 2 pi, a power for x, which I don't need here, and a power for y, which I'm going to make -1 so that it's in the denominator of my expression to calculate speed. I will type in those values and then click Apply. Now the column for speed is in my data table, and I'm ready to add it to an axis on my graph by clicking on one of the axis labels and selecting my newly created speed value from the list. After all that hard work, make sure to save your graph by clicking on the title in the upper left-hand corner.